So this video is on manual drafting of screw jack assembly. So the problem is like this: the details of screw jack are shown in figure. So part details will be given. Assemble the parts of the jack and draw the following views of the assembly. When the top face of the load bearing cup is raised to a height of 350 mm above the bearing surface of the body. So you can see from the image assembled model, the distance between that top and bottom surface in the assembly should be maintained as 350 mm. So in this position you need to draw front view in half section and top view. So before proceeding, please plan the drawing. See, the views are two views, one is front view and other is top view. Front view in half section and top view. Side view is not asked, so here we are not drawing side view, so only front view and top view is required. And the total height of the screw jack will be 350 mm, and that should fit in the sheet. Here I am taking a A4 sheet, so fitting in the sketch sheet. The sketch sheet is like this. So this is a sketch sheet, it's a A4 sheet. So the drawing should fit in this sheet. Okay, so front view and top view should fit in this sheet. So before you start drawing, please check whether the space is sufficient. Space is sufficient and the views will fit in the drawing sheet. Okay, so to check out, see here following the first angle projection. So for method of projection is first angle projection, and it is screw jack assembly. So two views are required. One is front view with half in section. So it is not mentioned right half in section or front half in section, so either is okay, but since it is not mentioned, so you can take any half, right side or left side half in section. So second one is the top view. Okay, so the uh, sheet is A4 and the drawing should fit in this sheet. So let's check out the dimension, maximum dimension required here. So let's see, this is the space required for front view, and top view is this. Side view is not asked, so I am not drawing side view here. So it is 350 mm, and the maximum dimension that comes here is 140. So total height is 490. So it is not possible to fit in this sheet. So this much space available is only this much space in A4 sheet, so can't fit in A4 sheet. So we'll take it scale 1:2. So that means whatever the dimensions, that's given dimensions, it, we need to plot for half the dimension. That means 1:2 multiplied by 0.5. So except angles, the angles will not change. Don't change the don't scale the angles will remain same. Only these uh, dimensions, like other dimensions except angles, other dimensions you need to take half. So to start with, so half of 350 is let's say 175, and from the top plane here I will measure 170, 180 I will take. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 16 17 18. It comes up to here. So and here required is 70 mm. 1 2 3 4 5. So it goes below this. So what I will do, I will take 70 mm the bottom, and remaining portion it will cross this top line, that's okay. So I will take 70 mm from here. This to 70 mm. So I will take this as the reference line. I'm just doing this to fit the drawing in the sheet, that's all. Okay, so you can take any scale. If not mentioned, you can take any scale, but if it is bigger sheet, you make it a bigger drawing. So since here the sheet is of A4, I am fitting the drawings in this A4 sheet with this scale. Okay. So to start with, it is from the body of the screw jack. So the dimensions or is 185 vertical height, and maximum diameter is 140. So I will start from the base is 140. So it is 70 mm. So I will mark this axis for this. This is the axis for screw jack body. So height is 185 mm, so it is 92.5 mm. Approximately I will take 92.5. 92 I can measure, 0.5 I can't measure, so I will take approximately 92.5. and here the top plane, it is 25 mm and then 70 mm. So it is 35 divided by 2, it is 17.5. So vertical height is 40 mm, so it is 20. So on the bottom plane it is 20 mm height, the thickness is 20 mm, so it is so like this. So here it is 50 mm, this dimension is 100, so reduced to 1:1 scale it becomes 50 mm. So taking 25 mm on either side, like this, and then I need to measure this dimension here. It is 33, half of 33 is 15 plus 1.5, 16.5. 16.5 on this side, then 12 point, measuring 12.5 and showing the inner detail here, 10, 12.5, and I will just draw a line. So it is not given how much depth it will go there, but I will just draw a line here, but the thickness is given here. Okay, so thickness is given, thickness is 10 mm, so it is measuring 5 mm here. I will draw a line parallel to this. So to draw parallel line I will measure at two locations, then I will join these points. So like this here. So at the bottom it is 1.5 mm, and at a distance of 25 up to here. So radius is 4 mm. Please use pro circle for this. For small arcs and circles, please use pro circle. So tangent arc, tangent to two lines here. In pro circle, you can just align the circle to these two lines and you can draw tangent arc. Similarly on this side. This is like this. So now so this right portion I am showing in section because front view with the right of in section. So I am showing this side in section. So here this portion is so this portion is a section. Okay, so now I will insert nut in this. So the nut drawing is this drawing detail will be given. So what is the criteria for assembly here is the nut should go inside. So first criteria is the axis should be aligned and then it should place on top plane of this body. So that is the constraint. So axis alignment, axis of the nut and axis of the body should align and then the bearing surface should coincide. So the bearing surface, the diameter is 90. So we will take here is it means 45. 45 above 45 is 22.5. 22.5 on this side, 10, 20, 10, 20, 22.5, it is up to, and 45 mm, it is up to here. So then this thickness here is 10 mm, so it is 5 mm, then here, okay, so it's a good practice if you use mini drafter and do on the drawing board. Okay, so since it's a limitation here and you need to use this A4 sheet, it's like this. Okay, so in using mini drafter and drawing board you can do very fast with very good drawing sketch. So it is 5 mm thickness here. Okay, on sides should be actually it's very small, so I will draw just by free hand. For smaller detail you can show with freehand drawings. Okay, so inside uh, it is a threaded region, so it is of a square thread of uh, mm, of pitch 7 mm. So here I will so actually you should refer to screw thread chapter for this drawing here, uh, and measure the minor diameter, how much the minor diameter, what should be the minor diameter for this screw thread for this configuration, and you should draw as per that. Okay, so since it's a very minute detail, I will take approximate value. But in software you make sure that the feature is available for threaded, so assign threading for inner surface of this nut, that is a square thread on so nominal diameter will be 38 and pitch is 7 mm. So that feature you please make it please assign in while using software. So here in drawing I can't make out that minute details, so I will take approximately here. So it is 38 means approximately so, so 19, so half of 19 is so 9.5 is the height is mentioned. From there it is uh, 45 minus 20, it is 25 from this surface. So from this surface it is 25 below this line. Okay, it is up to here, and I will just extend this, and also this line I will extend to the top portion, and it is for 10 mm, that means 5 mm, should be up to 5 mm only. And it's a small curve I will draw by freehand, but in actual practice, so that is the radius 5 mm, so make it radius 5 in assembly, please make it radius 5 while using software. Okay, so in manual drawing you can just draw freehand like this, and here I will just reproduce this dimension on that side using compass. And on this right,
No, join this class, the next class.
right, so this line is not visible, so it is like this. Okay, I will just extend this up to the axis. and also this line is also visible up to axis, it is visible. So it's like this. So now the spindle will come. So this is to be so 45 is 25, so 12.5. So it is from here it is total is 45 means it is 22.5. So 22.5 it is up to here actually. So here it is sectioning. So like this. So right portion in section, a left portion without section. So it looks like this. So now here I need to show the screw spindle. Screw spindle should come here. So for screw spindle we need to maintain as I mentioned earlier. So the dimension to be maintained is 350 mm. So total height is 350 mm. So 350 mm means it is um, just need to calculate this. Okay, so it is 350. I will erase here afterwards. So total height is 350. So 350 means to take the dimensions of all parts, so it is 185 so total dimension is 185 plus 20 . So I am taking these dimensions in assembly. So we can make out this total height from the bottom plane to the top plane should be 350 mm. So I am just uh, measuring the total dimension, and thereby I calculate the length of the screw that is outside the nut. So this is the length that is required so that it matches with the total height of 350 mm. So for that purpose I am calculating the dimensions here. So it is 185 plus 20 plus the screw spindle dimension is the portion of the screw spindle that goes, you see, some portion will go inside the nut and the body. So it is 83 minus 13 is 70 mm. It is 70 mm plus, and then the cup will come. So cup dimension is 42. So total is I just calculate. So total dimension is 185 plus 20 plus 70 plus 42 is equal to 317, and 350 minus 317 is 33 mm. So it is 33 mm length of the spindle that is outside 33 mm thread portion of the screw spindle that is outside the from the nut. So I need to maintain this distance here 33 mm from this. 33 mm means half of the dimension is it is 16.5 mm. So I will measure 16.5 mm from here, and so this is the reference. From here I need to show the screw spindle, so length of the screw spindle. So next is the screw spindle. So screw spindle series 240 minus 83. 240 minus 83 is so how much? 240 minus 83 is 157. Okay, 157 divided by 2, 78.5. So this length is 78.5. Okay, sorry, that's not correct. Actually it is 240 minus 70. Okay, so sorry, it is 240 minus not 83, because that projection length they should neglect where the cup will come. So that 13 mm you should not consider. So here 83 minus 13 is 70. So 240 minus 83. Actually no, that's correct, sorry. So that's correct, it is 78.5 mm length. So half of
The last code you joined, the signing to fill account.
78.5 mm, 76, 77, 78.5, like this. Reproducing by copying this dimension on other side.
No, sir, you did not join. Now you came. Okay. No problem, no, sir. No problem. So, I will send the link.
Here, and then you need to take this chamfer into account. So 1.5 mm, after 1.5 the thread starts, so take approximately 1.5 mm. So thread starts from here. So threading, this bottom portion is threaded region. So here I will show thread. And this chamfer, it is approximately approximate dimension. Actually, to precise, you should take the dimension referring thread forms, and there you should refer the square thread for 38 mm nominal diameter. What is the minor diameter, you should check, and you should plot as per that. So here I am just taking approximately and showing these dimensions. Okay, so then there is 10 mm, so 5 mm step here from the axis. So here this diameter here is 65, that is 32.5, 16.25 on either side. So I can't measure 0.25, I will take 16, but in software you can do that. It is 16 mm 16 mm on either side. Okay, so put this drawing, a continuation of this. So here the width is around width is measured, yeah, right. So and it is at an angle of 45 degree actually, chamfer at an angle 45 degree. So measure 45 degree, 40, this side also is 45 degree. So the height of screw spindle here is, it is 1083 minus 13 is 83 minus 13 is 70, 17 and minus 10 is um, 60, so it is 60 mm, means 30 on this side here. The 30 mm like this. Again 5 mm you need to measure from here for chamfering. Taking 45 mm, sorry 45 degree. It's going out of the page. Just similarly on this side it is taking 45-degree chamfer on this side. The okay, so now drawing the cup over this, since this is sectioning, so this line I can erase up to here. Similarly here, okay, to show section inner details there. And then so hole for Tommybar is at a distance of 35 mm from this point here. So 35 means 17.5 mm. Here. So I will take this as a reference. So Tommybar will come here like this. Okay. So take the before that I'll just complete this. So here the projection on the screw spindle is of thickness 13 mm. So 13 mm means 6.5 mm. So 6.5 mm projection here is up to here, and there it is, the diameter is uh, 22, so it is 11. So to here like this. On left side it is not visible because that goes inside. So right side is visible because there it is the sectional view. Then the whole of diameter 12 mm, so m12, so it is 3 mm. Depth is 35. 35 means 17.5. So total depth should be 35 mm, so it is 17.5, and draw like this. So in this also washer and the screw will come. Okay, so washer, special washer, and CSS screw. Okay, so the diameter of the washer is 35 mm. So 35 mm is the diameter. So it is 17.5. So 17.5 will fit here. Inner diameter is the inner diameter is 14.5 means 7.25 7.25 mm. So it will fit above this.
video ಹಾಕಿಂತ ಕಳಿಸಿರಲ್ಲ ಹಾಕಿದ್ರಾ ನೀವು
17.5
ಏನೋ ಹಾಕಿರ್ತಾರಲ್ಲ
means
ಹಾಕಿದ್ರಾ ಹೆಂಗ್ ಹಾಕಿದ್ರಿ ಅಲ್ಲಿಂದ ನಾವೇ ಇರ್ತಂತ ಹಾಕದ
it's around 8
ಎಲ್ಲಿ ಎಸ್ ಬಿ ಎಂ
around 8 mm.
ಹೌದು ಅಲ್ಲೇ ಇದೆಯಾ
Okay, so on this the thickness is 4 mm. I will show only the half portion. And then the screw will come here with CSK screw. Its length here is 15 mm. It is up to here. So this is the CSK screw. CSK screw with the washer. Okay, so now cup, drawing of cup. So base is 45 mm. So cup will be placed here. Its diameter of the base is 45 mm is 22.5, 11.25 approximately. You will take 11 mm. So it is to here, early here. Okay, it's almost matches with the top surface of the screw spindle here. So now the overall height is 21. Is it visible properly? Okay. So it is like this. So height measured from this point, it is 21 mm. So the cup will will be placed here. Okay, so the bottom plane of the cup should match with this. Okay, so it exactly fits here from this point to this point, and height I will measure from here. It is 21 mm. So 21 mm is up to here. It is going out of the page. It's okay, can't do anything. So here the diameter of the cup, diameter of the top plane of the cup is 65 mm. So I will take it is 32.5. It is 16.25 on either side. So it is 16 mm approximately. I will take 16 mm from here. It is 16 like this, and then should connect these two ends. So the inner details on left side is not visible because of the cup, so I will erase this. So this is a circle of diameter 5 mm. So I will just draw freehand. Please use pro circle for this. And then on this side it is uh, the thickness is 3 mm. It goes like this: 1 2 3 mm line, and it should be parallel to the inclined line. Take it approximately like this, and the thickness at the bottom is 6 mm. So it matches with this place of washer, so it is like this. Okay, and then here it is to a depth of the groove, so it is like this. So this is the uh, assembly drawing of screw jack. So it's still not complete. Hatching should be done. So this portion is the CSK screw, and it is threaded. I will show thread on this region here with chamfer at the end, and then like this. Okay, and then so this portion is the special washer, and this is portion is screw spindle, and this is cup. Okay, so the drawing is like this. So next part is Tommybar. So place for Tommybar is here. It is it will go inside from through this along this axis here. So it is to a depth of 31 mm. Okay, so that's optional. This dimension can vary. Okay, so it is I will take to this distance. Yeah, let it be uh, 31. So I will take to this length 10 mm. So that's the diameter is so 6 should be 6 mm like this. then we will extend this to a length of 31 mm. So here this it is the total length is 275 mm, so you need not to show the complete length. So here diameter is 20, so it is 10 mm on either side, sorry, 5 mm on either side, so like this. And then I will show to some length, because for longer length you need not to draw to full dimension, you can show with cut section like this. So I will just draw like this, that's okay. Okay, actually it's not proper, it's not exactly horizontal, sorry. So you can show knurling here, so some portion you can show with knurling. So like this. And then hatching is to be done. Hatching, while hatching, take care that you differentiate the parts. Okay, so hatching style for two adjacent parts should not be of same style, it should differ. If someone looks into the drawing easily, they should be able to make out the difference. Okay, so that's why hatching style should differ. Okay, so up to here it is a screw spindle, so and then here it is the special purpose washer. So here I'm showing different style of hatching like this. So like this you can complete hatching here, and also hatching here. I will not show hatching for complete assembly. Okay, so So it is like this. Okay, so it is should be like this. Okay, still if you can do a better drawing, I will be very happy. So please do a good drawing. Right, right. So this is the front view with half section. Okay, so now to draw the top view. So top view should come below here. So I will take the projection from the front view here. It's like this. I will take somewhere here. Okay, so this is actually I made it darker. It should be lighter actually to for recording purpose. I'm making darker. Reference lines should be thin. Okay, so here, so how to draw the top view? So see, top view, you should imagine that you are looking from this end. Okay, so you're looking from this end, that means like this. When it is viewed in this direction, what I can see is I can see the top plane of the curve, and then I can see the Tommy bar, and see this portion is outside. So this portion is outside. See, it is coming outside. Okay, so screw spindle is up to here. So this is outside. So you can see this portion. This portion you can see, and also this base portion also you can see. So base portion also you can see. So that's why first I will start with the base dimension. See, you should not you need not to take a dimension from using scale. You can just copy the dimensions using compass. So make use of the compass like this. Okay, so to copy the dimension, this saves a lot of time. So it is this dimension. Okay, so I will take here, but it matches there. Okay, so that's not correct because it matches, so I need to so lower this line. So I will take here. Okay, so I will copy this dimension. We'll copy this dimension here from here. So this base is the circle. a circle like this, and then I'll take this dimension. It is this dimension, the dimension of the nut here. Okay, and then the top plane of the cup, comes here, and then inner surface of the plane, it is this dimension, inner surface. Okay, what I am drawing here is the top view of the cup. Okay, so top view of the cup is this one. So top view of the cup, you can make out, you should draw like that. Okay, so on four corners I will just draw um, actually it is 5 mm radius, so 2.5 mm on either side. I will just take it approximately. It is 1 to 2.5 mm, 2.5 mm. So okay, I can just extend this to the bottom plane. Okay, similarly on sides it is 2.5 mm and 2.5 mm. So like this. Okay, so then the Tommybar. So inside the washer and the screw is also visible. So I will just draw a small circle here. So showing screw and washer. This circle is for washer. Okay, so one more circle. So this is a very small circle, so sorry, okay, I can't draw that anyhow. See, it will be a small circle showing screw. You can use pro circle for this purpose. So then so here comes
Sir, I have sent you MP lab manual, sir. Send it to Mosa. MP lab manufacturing practice.
So the top view of the assembly will be like this. Okay, so Tommybar, and inside this is washer and screw, and this is the cup, top plane of the cup, and this is the nut surface, and this is the base part of the body. Okay, so and the Tommybar extension you need to show like this. So this is the top view of screw jack assembly. So front view is like this. Okay, so total assembly is so like this. I can't show like this anyhow. Anyway, see it is just so top plane, sorry, front view, and then the top view of the screw jack assembly. Okay, so here the front view is in section, so I need to show the section plane. Section plane is so what section will give this view? Okay, so that is, if I remove this portion, if I remove this 1/4 of the portion, then so this 3/4 portion will give the, so 3/4 portion will give this front view. So that's why this portion is to be removed for this view. So it is like this. So section plane is will be like this. It goes up to the center, and then from there it is this horizontal line. Okay, so showing, I will make this hands thicker. Here also, then showing arrowheads here. So drawing is going out of the boundary. So like this, I can give the name of the section plane as yes. Okay, so along with this, you need to complete show the major dimensions, and then part numbering and bill of materials with this. So this completes this demonstration on sketching of screw jack assembly. If you have yeah, okay, so thank you, thanks a lot.